Hello and welcome everyone. Thank you so much for joining us for the WaterWise gardening class on drip irrigation. My name is Stephen Glenn. I'm an environmental services specialist here with Ventura Water, and today we're going to be going over the basics of drip irrigation. So we'll be discussing everything from installation all the way over to maintenance. If you have any questions about any of the material, please feel free to shoot me either a call or an email. And if you would like more information on drip irrigation, please visit the last slide. I've got lots of great links on there that will give you some more information. So let's jump right into it. So what is drip irrigation? We've all seen it before. It's become really popular over the past few decades, and we've seen people swap out their traditional overhead sprays and start watering their plants with drip irrigation. So all it is, it's a low pressure, low volume system that delivers your water directly to the plant. It can sometimes be referred to as trickle irrigation or point source irrigation. Next, we'll touch on a little bit of the history of drip irrigation. So drip irrigation actually dates all the way back to the 1st century BC in ancient China, where farmers would use buried unglazed pots to irrigate their crops. These pots were sometimes referred to as olas, and they used the tension from dry soil to draw water from the inside of the pot. Then in more modern times, we've seen farmers using perforated clay and plastic pipes to distribute water to different crops. The biggest jump in the use of drip irrigation occurred post-World War II with advances in modern plastic and injection molding technology. During this time, 2 Israeli engineers were able to develop the first drip emitter, and this allowed farmers and homeowners to regulate the amount of water that was being delivered to each plant. Some of our application areas for drip irrigation. Drip irrigation is going to be great for your native plants, your shrubs, your trees, your fruit and your vegetable gardens, and your sloped areas. Essentially anything that isn't a grass area, it's going to work great for. So this leads us to our next point. It's not going to be ideal for your lawn areas or your high volume ground cover. So there is subsurface drip irrigation, which is actually buried underneath the ground. And you can use this to irrigate your lawn, though I don't recommend it because if one of the emitters gets clogged up, it's going to be hard to hunt down. Next, we'll touch on some of the pros and cons of drip irrigation. So we'll start off with some of the pros. Drip irrigation is very efficient. It's only going to deliver water to exactly where you need it to be. So you don't have to worry about watering your sidewalks or dirt areas or even the side of your house. The next pro is going to be minimized runoff and erosion. Since water is applied at such a slow rate, you don't have to worry about your ground becoming oversaturated and then your soil and your landscape chemicals or fertilizers running off into the storm drain and into our stormwater system. You're going to have fewer weeds since weeds need access to water and water is not being distributed over the whole landscape area. There's not going to be enough water for them to uptake and grow. You're going to have less frequent fertilizing. This points back to our minimized runoff. Since the water is being applied at such a slow rate, you don't have to worry about your landscape chemicals and fertilizer running off of the landscape, which means that you are going to have to fertilize less often. You're going to have less evaporation. Once again, since the water is applied at such a slow rate, the soil has time to uptake all of that water, preventing it from being uptaken into the atmosphere. And our last pro that I have is going to be really easy installation. After you get past your irrigation valves, everything just snaps into place. You don't have to worry about trenching anything out or cementing pipes together, anything along those lines. It's very simple, and the maintenance is very simple as well. Unfortunately, drip irrigation does have some downsides to it, so here are some of the cons. You're going to get clogged emitters since it's such a low pressure system and it's sitting in the dirt. It's prone to sucking up sediment and different small particles that'll end up clogging your emitter. So you'll need to make sure that you're flushing out your system frequently and that you're changing out any clogged emitters that you have. Next con is it's prone to being chewed up by rodents and other animals. Since the piping or the tubing is laid just directly on top of the ground, it's very exposed and it's a bit soft, so rodents do love to chew through it. Our next con is it's always exposed to the sun. Once again, since it's laying on top of the ground, sun exposure over time is going to start to break down some of the materials that we use. For this reason, you're going to want to give it a nice layer of mulch. You don't need to bury your line. I don't recommend that you bury the line, but you definitely want to cover it with a bit of mulch to protect it from the sun. The last downside that we have is it's going to require frequent maintenance. Since your materials, none of them are cemented together and everything's exposed on top of the ground, your tubing is going to become disconnected. You're going to have clogged emitters. So it's going to require some extra maintenance. The good news is the maintenance is really simple, and since everything is exposed, it's very easily accessible. So you don't have to worry about having a broken pipe under the ground that you're going to need to dig up and replace or anything like that. Everything is going to be pretty visible, and if you walk your system frequently, you should be able to pick these things out. All right, our next item is going to cover the different components of drip irrigation. So I will include some pictures for some of these different components. So our first is going to be our main line. This is going to be our water source that's going to supply our irrigation system. You'll usually see it in your front yard. It usually comes right up out of the ground, and you will see part of the line running into your house, and then it will split off to your irrigation area. Our next component is going to be our isolation valve. So this is usually located right up at the top of your water source or main line. And it's going to be a manual, usually a quarter turn valve that you can use to shut off the complete landscape area. Now you commonly see these in two different types of valves. One of them is going to be a gate valve, and the other one is going to be a ball valve. I recommend that you use a ball valve because it's less likely to fail. They are a bit more expensive, but in the long run, I think it's well worth it just to go ahead and get yourself a ball valve. And I've included a picture here. We've all seen this. It's just a quarter turn valve that you'll use anytime that you're doing any maintenance on your system. You're going to want to turn off the water at this valve. Next item we have is a master valve. We rarely see this, but it's becoming more popular. And it's going to be your backup or emergency valve. You'll definitely want to install one of these. I've seen a lot of valves that fail and they stick on, and they can stick on for weeks at a time before people notice. So your master valve is going to be your first line of defense for that. And this is going to be placed directly after your isolation valve, and it can be hooked into your controller. So what can happen is if one of the valves at your valve manifold that's controlling one of your areas, if that gets stuck open, your master valve is still going to close, and it's going to prevent that valve from continuously running. So very important to have. And you can also hook up a flow sensor to this as well in case a pipe breaks. It'll send a signal to your master valve telling the system to shut off and prevent that continuous use of water. The next component that we have is going to be our valve manifold. So this is just going to be your grouping of valves. You will usually see this an area of more than one valve. It'll be usually pretty close to where your main line comes out of the wall. They can be far, but usually they're pretty close. And this area is what's going to control the water going out to your landscape. This leads us to our next item, our anti-siphon valve. So you don't necessarily need to have an anti-siphon valve. I do recommend an anti-siphon valve because they're cheap and they have a built-in backflow preventer in them. So you're definitely going to want to have a backflow preventer. I think that this is going to be mandatory on all systems, and what it's going to do, it's going to prevent the water from your landscape area from moving back into your potable line. So especially important for drip, since it's laying on the ground, it's prone to getting dog urine and feces or any animal urine and feces into it, and you definitely don't want that going back into your house line. So an anti-siphon valve is going to be very important. Like I said, you don't need to have an anti-siphon valve, but definitely some sort of valve which is going to control the water going in and out to your landscape. This can be either an automatic valve or a manual valve. The next item that we have is your filter. This is going to be very important for your drip irrigation because the emitters are very prone to being clogged up. So your filter is going to filter out any small particles in the system, and it's going to prevent that from going out into your system. So I would recommend getting a filter that is 150 microns or more, and this is the size of the filter, the size of the holes within the filter, and the higher you go, the finer the filter becomes. And you're going to need to clean out this filter once every few months, and this should prevent your emitters from being clogged. The next item that we're going to have is our pressure regulator. This is going to be really important. A lot of houses in Ventura, they already have a pressure regulator at the house, but this does not cut it down to what we need. Drip is rated to operate at about 25 psi. So we'll use a small piece of plastic pressure reducer that's going to cut down that pressure, and it's going to prevent your emitters from blowing off. So if you just let your drip system run at the normal house pressure, you're going to have emitters blowing off left and right. So this is a very important component to put on. The next item that you're going to have is your adapter. So this is how we're going to move from your PVC parts into our tubing parts. The next item that we're going to have is our tubing. So this is how you're going to deliver the water through your landscape to different plants. It comes in a variety of different sizes. Some of it has built-in emitters. They're called inline emitters. That's actually built into the tubing. Others you'll have to punch in and connect in your own emitter or even a smaller line. So like I said, this comes in a variety of different sizes. Your typical mainline drip tubing is going to be a 1/2 inch, and it's common to see lateral lines come off this that are 1/4 inch, sometimes referred to as spaghetti tubing. I would recommend, if possible, keeping just a 1/2 inch line. The more lines that you have connected in different fittings and such, the more likely they are to become disconnected when you're doing maintenance throughout your landscape. So just a recommendation. It's not going to work for all landscape areas, but if you can, I would recommend just keeping that 1/2 inch line. The next item that we have is our fittings, and our fittings are going to be used to attach our different components to each other. Our common fittings are going to be T's, elbows, couplings, things like that, and they do come in compression and barb. I tend to use compression fittings just because the barb fittings, sometimes it'll cause the edge of the tubing to split after it's been sitting out in the sun. So you can use either one, and you don't have to glue or cement any of these pieces together. They just fit over the drip tubing. The next item that we have is going to be our drip emitters. So there are many different kinds of drip emitters. They all have different pros and cons. Like I said before, some emitters are actually built into the tubing. And this is how we are going to deliver and regulate the amount of water that is delivered to each plant. And these range all the way from about 1/2 gallon an hour in excess of 4+ gallons an hour. And the last item that we have as far as components go is going to be our end cap. So the end cap is what you're going to place at the end of your main line, and it's going to stop the flow of water from just spilling out onto your landscape. And you're also going to use this to flush out your system a couple of times a year. So I like to use a figure 8 end cap, and the tubing just goes through it and fits over it, bends upon itself, and creates a kink in the tubing to prevent the water from spilling out. I would shy away from using a zip tie as an end cap. And here I have a couple different links to show all the different components in use. So a couple of really great diagrams in here. I do recommend that you look at both of them. The first one shows irrigation from our main line all the way out to our end cap. So everything in between there. It is missing a master valve in this example, but it gives you a really good visual idea of the way that things work. The next link I have here is a controller wiring diagram. So very simple, but you can take a look at it. It's going to show each wire coming off from each of the solenoids on the valve, and then the common wire. All right, so next we will jump into the planning of our drip system. So the first important thing that you're going to want to do, if possible, is take a detailed sketch of the area. It doesn't need to be perfect. We're not looking for engineering renderings necessarily, anything like that. Just something simple that's going to give you a good idea of the area that you're working with. And then if you can, if possible, do your plant layout. Try to figure out the area that your plants are going to take up at full maturity. And then this is going to help you put together a nice materials list later on. So very important just to take a nice semi-detailed sketch that's to scale. So what I like to do is use graph paper, and each box I use as a 1x1 area, so 1 square foot for each box. And as you can see, my black line right here is going to be my future half line tubing. I'm not going to use any 1/4 inch tubing, and I'm just installing one kind of low water use plant throughout the entire area. So this is going to help me put down a nice list, which is going to be our next step. So like I said, our next step in planning is creating a detailed materials list. Try to be as detailed as possible. That way we only need to make one trip to our hardware store and we can get the whole system put together in one shot. So what I've done is I've used my sketch from above to figure out how much tubing I'm going to need, how many emitters I'm going to need. I know that for this project, for my low water use area, I'm only going to need one valve. A quick note on this is to only use 200 feet of tubing per valve. Very important, even though we're not too worried about pressure. 200 feet is a nice suggestion, just to make sure that you don't lose pressure at the end of that line. So we're within my sketch, we're within that 200 feet, so I'm only going to need one valve. And then I just went down the line and figured out how many different fittings I'm going to need, and then all the various parts in here. So try to make it the most detailed list you can. All right, the next stage in our planning is going to be creating a water budget. Now there are many ways to do this, and if you do take a look at the last page or the last slide of this presentation, you can look into Quell, and they give a really in-depth look into how you can create a great budget. It does take a long time, and I think that using the MWello standard to create a budget is probably going to be the most simple, and it's the most widely used as well. A lot of different agencies actually use this budget tool to create a landscape budget for their customers, and it's becoming increasingly popular as time goes. So what we're going to do to create this budget is we are going to create our maximum applied water allowance. So this is going to be the maximum amount of water that we want to put on our landscape. And we're going to compare this to our estimated total water use. So our maximum applied water allowance takes into account all of our landscape areas that are going to require water. It doesn't take into account what plant type or what kind of irrigation we're using. Our estimated total water use is going to take those things into account. So they will look a little bit differently, and the goal is to have our estimated total water use be less than our maximum applied water use or allowance. So we will look farther into this, and I will show you some of the different things that you're going to need to do this. So then you can create a budget and kind of use this budget to break down and give yourself a monthly budget, which you'll then use to program your timer. Okay, so the first item that we are going to look at is we're going to need to determine our maximum applied water allowance. So for this, we're going to need our evapotranspiration, which is essentially the water that we're losing into the atmosphere from soil and plant. So you can find this on the CMIS website, and this will give you a zone map. I actually looked into exactly Ventura's evapotranspiration rates, and these are averages. So you can click on this link below, and that will take you to a zone map. where you can get these numbers. The other item that you're going to need is the total landscape area. Like I said, we don't need to divide this up into low water or high water use areas. It's just taking the whole landscape area into account for this. The other two numbers that you see here, they're fixed numbers. The 0.62 is just going to be a conversion factor, and the 0.55 is a standard adjustment factor. So the next item that we're going to need to do is determine our estimated total water use. So for this, we're going to need a couple other numbers. We're going to use that same evapotranspiration number that we got earlier. We're also going to use an irrigation efficiency number. And I have posted these right here for you to see. They're pretty fixed numbers. You can go more in depth and get a more exact number by doing an irrigation audit. But just for a quick reference, you can use these numbers right here. The next item that we're going to need is our plant factor. So for your plant factor, you can look at the WUCOLS list that I have posted at the very end slide of this presentation, and that is going to give you that plant factor number based on the watering requirements of the specific plant. And then the last thing we're going to need is we're going to need the areas for the individual area, the individual hydrozones that we're using. So as you can see here, I've done this equation 2 separate times, and then I've added them together to get the total water use, estimated total water use that we're going to have. So here is our total budget right here, and what I've done is I've actually split it up into the 12 months so we can figure out how we're going to program our controller to make our water use fit within this budget. So try to get it to fit to the estimated water use, and try not to exceed the maximum water allowance. Okay, and then the next item we have is going to be our maintenance. So as we discussed earlier, the system does require, I would say, more maintenance than your typical overhead spray system because it is laying out and exposed, and the drip emitters are prone to getting clogged up. So to prevent our emitters from getting clogged up, you're going to want to clean out your filter as often as possible. I would say once every few months, and all you need to do is unscrew the end cap of the filter and take out the screen and just rinse it out under the sink or the hose. And this should wash out any debris that you have clogged up in there that might eventually make their way through the screen and into your emitters. The next thing that you're going to want to do is you're going to want to walk your system and just check out your different emitters, make sure everything is working correctly. And pick out a time to do this. Most folks run their system really early in the morning, so they rarely get the chance to actually walk the system because it's coming on before they wake up. So take a walk through your system. Make sure you don't have any blown off or clogged emitters. Make sure rodents haven't chewed through any of your lines, and make sure none of your tubing is disconnected. Next, to clogged emitters, you're either going to want to try to flush these out, or you can just replace them. They're really cheap, so sometimes it's easier just to pop the old one off and install the new one in its place. That's my recommendation. Next, you're going to want to flush your system. So I say to do this annually, but I would recommend as often as possible, try to open up that end cap and just flush everything out of the system. Another very important thing is to flush your system out right after you've installed it. This will prevent any of the dirt or gunk that's got up in there during installation from clogging your emitters later on. And this is something I think that's overlooked often, and this just sets you up for failure. You're going to have a lot of issues if you don't flush your system out before the first time you use it. And then the last thing I have for maintenance is to adjust the irrigation controller. So back to our budget. Create your monthly budget and try to stay within that range, and you'll need to go to your irrigation controller and adjust those times. So that is it for our maintenance. There are other maintenance items in here. These are the most important ones that I think that everyone should be practicing. Our next link is just going to cover some of the helpful links that I think that you should take a look at. So the first link is going to be to that WUCL's plant list. Now this is a really, really big plant list, and it's going to tell you some of the different watering requirements of the different plants, and it's going to give you that plant factor. And I believe that you can download this as an Excel spreadsheet. That way, if you have a certain plant that you want to search, you don't have to go through the thousands of items. You can just simply search for that item and see the plant's watering requirements. The next link is to some different plant information. This is from SM Growers, and this is going to tell you plant size at full maturity. So this is going to be great for when you're planning out your drip irrigation system. It's going to tell you the watering requirements and full maturity plant size, so you can account for those things. The next thing is going to be the MWELO ordinance. I do recommend that you look into this, and this will give you a deeper look at creating that budget. The next item I have is the QUEL manual. So this is for the Qualified Water Efficient Landscaper. And this is a really great resource, even beyond just drip irrigation. This gives you a really good look into all things landscapes. But there's some really good budgeting tools in here. It'll show you how to audit your current system, both drip and overhead sprays. So I definitely recommend that everyone look at this QUEL manual. It's a bit long, but there's a lot of good stuff in there to look at. The next thing I have is going to be a more in-depth description of some of these components. So we just kind of briefly went over them. We were a little bit limited on time. So I would recommend that you go into here and you can see all of the different kind of emitters, different kind of valves, different kind of shut-off valves. It gives you a really nice description of all the different components that we've talked about. The next item I have, the next two items kind of go together. So this is going to be Home Connect. So this is a really good way to keep an eye on your system. So with the city's new smart meters, we have Home Connect, which is an online portal for all residents to go into, and you can actually see almost real-time water use data. So you can see hour-to-hour profiles on how much water you have used. So you can run your irrigation cycle. Once again, usually they run really early in the morning, so before anyone's up. So you can go into Home Connect and you can see how much water you've used during your irrigation cycle, and you can use that to help adjust your irrigation controller. So a really great resource. And then the last item I have is a video to how to read your new smart meter. I think it's really important, and I think that you should use this when you're setting up your system, just to see how much water your system uses, let's say in a minute, and then you can use that to build on to your irrigation schedule. So so those are the helpful links that I have. And my last slide is for questions. Unfortunately, this is a recorded class. Our live event was cut short, so we went ahead and re-recorded it. But if you have any questions, please feel free to shoot me an email or a call. I am available to answer any of your questions, and any questions that I am not able to answer, I will point you in the right direction of someone who can answer those questions. So that is it for me. Once again, thank you everyone so much for joining us for this WaterWise gardening class on drip irrigation, and have a wonderful day.